Can we build a stereo image mastering plugin that is better than what's out there? And I'm going to be doing plenty of more of these things, so make sure to like, click subscribe, and tick the notification bell. We're going to build this processor in DDMF Meta plugin. It's an incredible, powerful sandbox audio tool. My friend Bill Podolak over at iZotope introduced me to it, and we've been using it to bounce ideas back and forth. It has opened a floodgate for putting concepts in my head and thinking of these concepts and being able to put them somewhere so I can actually use these processors. But if you haven't got this plugin, don't worry. The core concepts around routing, in which we'll explore, are still valuable for you to learn from, and you can adapt these into your own workflow. So let's establish the core concepts around stereo imaging and mastering. The character of the stereo image and how we orally perceive it is a direct result by the differences in phase between the left and right channel signal. Many stereo image processors aim to introduce delays in the time domain between the left and right channel, and that exploits the psychoacoustics of the Haas effect. Yet it's not suitable for mastering applications, as a time domain shift in phase between two channels not only affects the difference between the left and right signal, but also their relevant coherency with the makeup of the center image or the mono signal. A more called upon form of processing in mastering for applications in mastering is mid-side processing, and this is where the engineer has access to an encoded sum difference components of the original signal independent from one another. And it's an elegant way to manipulate aspects of the stereo image in mastering without destroying the center image. I felt there was a little bit more opportunity to further exploit mid-side processing, which hasn't been considered before in stereo images. So I've drawn inspiration from two mixing engineers' methods, both in the way Andrew Sheps lays out processing for vocals and how Craig Bauer mixes using parallel channels as an additive technique to introduce unique qualities into a signal path. First, I'm going to show you this schematic I drew last week in the morning. This details a signal which is encoded into mid-side, and then that mid-channel remains untouched, directly going to the decoder. And the side signal is sent out to 4 different processing locations, all which sum back through a mixer, and the user can interact with different ways of manipulating the stereo image to taste. Now, it's a subtle effect, but it's quite an effective one to manipulate this stereo field. And I'll show you how we set this up. On this 4-channel mixer, we've got 4 channels which we can blend through. This first one just takes the side signal. So we can boost the side up, we can boost the side down, more gain, it's wider, less gain, it's narrower. That's normal mid-side channel or matrix processing. The second is processed by TDR Kotelnikov in parallel. So that side signal goes to this compressor. In parallel, it gives the user autonomy to increase the RMS of the side signal, because they can compress this channel very, very hard and then blend it back in to a new sum of the side signal, which is important. Now, the third processor is a harmonic generator by Hornet Harmonics, and this is for adding character or tone to the stereo field. And I chose odd order harmonics because it keeps the waveform symmetrical, and this is important because we're going to be decoding this signal back to left and right. And then on the 4th and final processor, I've got a high pass filter at 5 kHz and more harmonics, which sort of emulates the Aphex Aural Exciter for that air. So at the end of the day, what you end up with, let me just get rid of these and hide all these, where are we, is we've got overall width, overall weight, overall character, and overall air. And because of the aspects of this processor having harmonic distortions and the fidelity of making sure this mid-side processor decodes from mid-side to left-right accurately, I've chosen to oversample this as well to avoid aliasing distortion. And at the end, all I'm left with are these 4-channel mixers, which I can use to blend in weight, character, air, width to the stereo signal. It's pretty cool. Let's have a listen to how it sounds now. Okay, I really like how these odd order harmonics make the guitar pop. The parallel compression, sort of not here, not there. I think the side signal on this is already pretty well controlled, but these odd order harmonics parallel on the side signal, I like. I think there's a bit of refining we can do with these parameters if it was ever frontward facing to a user as an actual marketable plugin, because these, like when you're down at -40, -50, it's just doing nothing, and it just seems like a waste on user front end. But yeah, that was interesting. So you can see that parallel compression. I'm doing like 12 decibels of gain reduction on the parallel compressor, but for like trap music, for like dubstep music, it gives you that wall of noise. Like if you want more dubstep, I don't know why I said trap, but for trap music, I said it again. For dubstep music, you want that wall of noise, that intense, like in your face sound. That parallel compression on the side signal gives you that. It gives that stereo field, everything up and in front of you without necessarily going over and taking up too much headroom. So have another listen. And I'm using a little bit of the air as well, just to keep things exciting. Now, the final one, this more pop ballad, a bit more pulled back. It's a nice song, Jas, Wish You Well. We've had it on the channel before, I've been working on it. Have a listen to this.
Easy to say it was mutual, but don't think it was in my mind. Say that we both walked away when really you left me behind.
Okay, so on the pop ballad one, I think the only thing that really made a difference was this parallel compression. The harmonics I wasn't a big fan of, but they do play a purpose in this processor. So what do you think I have to change on this? Let me know in the comments, because I have a few ideas. The first one is the compression is really good, and I think maybe using something like something that creates a gain trace like the impact module in Ozone could be really good, so that way it's a variable threshold and you don't have to set thresholds and whatnot. It's just always a constantly working sort of downward compression for this. The other one is the harmonics. The odd order harmonics are okay and it works on some material, not all material. It'd be interesting to develop some sort of harmonic profiles maybe for different characters. The air one was the only one where I was like, that's a little bit of a waste. I don't think we need it. I just think we need compression and harmonics in parallel. The air one is sort of like, I was using it, but I wasn't necessarily liking it. I was like using it, I'm like, oh, it's doing a bit, but I don't know if I necessarily liked it or would reach for it. So I think developing harmonic profiles, I think that's the first thing I got to do, is develop some harmonic profiles for this. And then the compression creates maybe not a profile, but a different way of manipulating threshold, or maybe having a dependent control which manipulates this threshold based on user input, so that way you can have different characters of compression or ways of controlling it. Because I like the process, I like the concept, and this is what I mean. I want to bring these concepts to you and we can discuss and develop and flesh them out, because they're fun. It's cool, it's a cool processor. And what I might do is, if you use DDMF Meta plugin, let me know and I'll send you the file for it so you guys can play around with it. So yeah, hope you enjoyed that. Until next time, take care.